One of the most captivating features of Uranus's magnetosphere is its variability. As the planet rotates, which it does every 17.24 hours, the magnetic field wobbles and twists, creating a constantly changing environment. This dynamic nature results in a magnetosphere that is not symmetrical and fluctuates in intensity and shape. This phenomenon is due to the fact that Uranus's magnetic field is generated by a different mechanism compared to Earth. Instead of a molten iron core, Uranus likely has a layer of ionic water-ammonia ocean, which contributes to its unusual magnetic properties. Another intriguing aspect of Uranus's magnetosphere is the presence of intense radiation belts. These belts are similar to the Van Allen belts found around Earth, but are much stronger and more variable. The radiation within these belts is so intense that it can pose significant challenges for any future missions aiming to explore Uranus up close. The high-energy particles trapped in these belts can damage spacecraft electronics and pose risks to human health. Uranus also has auroras, similar to the northern and southern lights on Earth. However, the auroras on Uranus are not as visually stunning as those on our planet. They are faint and difficult to detect, primarily because they occur at wavelengths that are not visible to the human eye. These auroras are caused by the interaction of the solar wind with Uranus's magnetic field, creating a beautiful yet elusive display of light. Recent discoveries have also shown that Uranus's magnetosphere can trap and accelerate particles to extremely high energies. This process is still not fully understood, but it is believed to be linked to the planet's unique magnetic field configuration. Understanding this mechanism could provide valuable insights into similar processes occurring in other planetary magnetospheres and even in astrophysical environments. One of the most exciting recent findings is the detection of a plasmoid in Uranus's magnetosphere. A plasmoid is a large bubble of plasma that is ejected from the magnetosphere into space. This discovery was made using data from the Voyager 2 spacecraft, which flew by Uranus in 1986. The presence of a plasmoid suggests that Uranus's magnetosphere is highly dynamic and capable of ejecting significant amounts of energy and material into space. In summary, Uranus's magnetosphere is a fascinating and complex system that continues to surprise scientists. Its unique magnetic field configuration, intense radiation belts, elusive auroras, and dynamic processes make it a subject of ongoing research and interest. As we continue to study this distant planet, we are likely to uncover even more intriguing features and deepen our understanding of planetary magnetospheres. Uranus, the seventh planet from the Sun, is often overlooked when we talk about our solar system. But did you know that this ice giant has an intriguing collection of moons that are as fascinating as the planet itself? Uranus has 27 known moons, each named after characters from the works of William Shakespeare and Alexander Pope. Among these, the 5 largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, stand out due to their unique features and the mysteries they hold. Miranda, for instance, is a moon that has puzzled scientists for decades. With its bizarre, patchwork surface, featuring canyons up to 20 kilometers deep, it looks like a celestial jigsaw puzzle. Recent data suggest that Miranda may have experienced a significant geological upheaval. Ariel, the brightest of the Uranian moons, is a world of contrasts. Its surface is marked by vast canyons and ridges, suggesting a history of intense geological activity. New research indicates that Ariel might have cryovolcanoes, which are volcanoes that erupt with water, ammonia, or methane. Umbriel, on the other hand, is the darkest of Uranus's major moons, reflecting only a small fraction of the sunlight that hits it. Its surface is old and heavily cratered, indicating that it has been geologically inactive for a long time. However, recent observations have revealed some bright spots on Umbriel. Titania, the largest moon of Uranus, is a world of ice and rock. It has a network of enormous canyons, some of which are over 1,500 kilometers long. Scientists believe that Titania may have a subsurface ocean, kept liquid by the heat generated from the radioactive decay of elements in its core. Oberon, the second largest moon, is a distant and icy world. Its surface is heavily cratered, with some craters showing signs of dark material deposits. These dark deposits might be the result of cryovolcanic activity or impacts from other celestial bodies. In recent years, the study of Uranus's moons has been revolutionized by advances in telescope technology and computer simulations. High-resolution images from the Hubble Space Telescope and data from ground-based observatories have provided new insights into these distant worlds. Additionally, future missions to the outer planets, such as the proposed Uranus orbiter and probe, aim to explore these moons in greater detail, potentially uncovering more secrets about their formation and evolution. As we continue to explore our solar system, Uranus and its moons remind us of the incredible diversity and complexity of the celestial bodies that share our cosmic neighborhood. Each moon has its own story to tell, full of geological wonders and potential for future discoveries. To understand Uranus's tilt, we need to look back at the history of our solar system. Scientists believe that Uranus did not always have such an extreme tilt. The most widely accepted theory is that a colossal collision with an Earth-sized object billions of years ago knocked the planet sideways. This cataclysmic event would have not only altered Uranus's orientation, but also its internal structure and atmospheric composition. Recent data from the Hubble Space Telescope and other observatories have provided new insights into this theory. Detailed observations have revealed that Uranus's moons and rings are also tilted at similar angles, suggesting that the entire system was affected by a massive impact. Additionally, computer simulations have shown that such a collision could create the planet's unusual magnetic field, which is offset from its rotational axis by 60 degrees. But the story does not end there. Uranus's extreme tilt has profound effects on its climate and weather patterns. Unlike Earth, where seasons are caused by the axial tilt of 23.5 degrees, Uranus experiences extreme seasonal variations. Each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. This results in dramatic changes in temperature and atmospheric dynamics. For instance, during the long summer, the temperature can rise significantly, causing massive storms and high-speed winds that can reach up to 900 kilometers per hour. One of the most fascinating recent discoveries is the presence of diamond rain on Uranus. Scientists have long suspected that the extreme pressure and temperature conditions deep within the planet could compress carbon into diamond. Recent laboratory experiments have confirmed this possibility, suggesting that diamonds could be forming and falling like rain in the planet's interior. Moreover, the study of Uranus's tilt and its consequences extends beyond our solar system. By understanding the dynamics of Uranus, astronomers can gain insights into the behavior of exoplanets with similar tilts. This knowledge is crucial as we continue to search for habitable worlds beyond our solar system. In summary, the extreme axial tilt of Uranus is a captivating mystery that continues to intrigue scientists. From a colossal collision to diamond rain, the planet's unique orientation has far-reaching implications for its climate, weather, and even its magnetic field. In recent years, with advancements in telescopic technology and space missions, we have gained unprecedented insights into the atmospheric composition of Uranus. One of the most intriguing discoveries is the presence of clouds made of hydrogen sulfide, a compound that gives rotten eggs their distinct smell. This finding was confirmed by the Gemini North Telescope in Hawaii, which detected the spectral signature of hydrogen sulfide in the upper atmosphere of Uranus. These clouds are not just a curiosity. They provide crucial clues about the formation and evolution of Uranus. The presence of hydrogen sulfide suggests that Uranus formed in a colder region of the solar nebula, where such compounds could condense. This contrasts with the gas giants Jupiter and Saturn, where ammonia clouds dominate due to their formation in warmer regions. Another fascinating aspect of Uranus's atmosphere is its extreme weather patterns. Despite being tilted at an angle of 98 degrees, resulting in extreme seasonal variations, Uranus has surprisingly active weather. The planet experiences powerful storms, with wind speeds reaching up to 900 kilometers per hour. These storms are thought to be driven by the internal heat of the planet, which, although not as significant as that of Jupiter or Saturn, still plays a crucial role in shaping its atmospheric dynamics. In addition to storms, Uranus also exhibits a unique phenomenon known as dark spots. These are massive storm systems, similar to Jupiter's Great Red Spot, but much darker and less understood. The Hubble Space Telescope has captured images of these dark spots, providing valuable data for scientists to analyze and compare with other planetary storms. One of the most exciting recent developments is the proposed Uranus Orbiter and Probe mission by NASA. If approved, this mission would send an orbiter to study Uranus and its moons in detail, along with a probe to descend into the planet's atmosphere. This mission has the potential to revolutionize our understanding of Uranus, much like the Galileo mission did for Jupiter and the Cassini mission for Saturn. As we continue to explore Uranus, we are reminded of the vastness and complexity of our solar system. Each discovery brings us closer to understanding not just Uranus, but the processes that govern the formation and evolution of planets. The clouds of Uranus, with their unique composition and dynamic weather patterns, are a testament to the diversity and wonder of the cosmos. Stay tuned as we bring you more updates on the latest discoveries and missions exploring the far reaches of our solar system. Remember to like, subscribe, and hit the bell icon for more fascinating content about the universe. Uranus, unlike Jupiter and Saturn, is classified as an ice giant. This distinction comes from its unique composition. While Jupiter and Saturn are primarily composed of hydrogen and helium, Uranus has a different story to tell. About 80% of its mass is made up of a hot, dense fluid of icy materials, water, methane, and ammonia, above a small rocky core. This icy composition gives Uranus its characteristic blue-green hue, thanks to the methane in its atmosphere, which absorbs red light and reflects blue light. One of the most intriguing aspects of Uranus is its atmosphere. It is composed of hydrogen, helium, and methane, but recent studies have revealed something even more exciting. Scientists have discovered that the upper atmosphere of Uranus contains hydrogen sulfide, the same compound that gives rotten eggs their distinctive smell. Another fascinating feature of Uranus is its extreme axial tilt. Unlike any other planet in our solar system, Uranus is tilted at an angle of 98 degrees. This means it essentially orbits the Sun on its side, leading to extreme seasonal variations. Each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. This unique tilt also affects the planet's magnetic field, which is tilted 59 degrees from the rotational axis and offset from the center of the planet. Uranus's magnetic field itself is a topic of great interest. Recent data from the Voyager 2 mission, which is the only spacecraft to have visited Uranus, shows that the magnetic field is lopsided and constantly changing. Unlike Earth's magnetic field, which is relatively stable, Uranus's magnetic field flips and flops as the planet rotates. This dynamic magnetic environment could have implications for the planet's internal structure and atmospheric dynamics. Speaking of the Voyager 2 mission, it provided us with some of the most detailed images and data about Uranus. One of the surprising discoveries was the presence of 27 moons, each with its own unique characteristics. For instance, Miranda, one of Uranus's moons, has one of the most varied and extreme landscapes in the solar system, featuring giant canyons, ice cliffs, and surface grooves. These moons, along with the planet's faint ring system, add another layer of complexity to Uranus's composition and structure. In recent years, there has been a renewed interest in sending a dedicated mission to Uranus. Scientists hope to study its atmosphere, magnetic field, and moons in greater detail. Such a mission could provide invaluable insights into not just Uranus, but also the formation and evolution of ice giants in general. With advancements in technology, we are closer than ever to unlocking the secrets of this enigmatic planet. To wrap up, Uranus is a planet of extremes and mysteries. From its unique composition and stinky atmosphere to its extreme axial tilt and dynamic magnetic field, Uranus challenges our understanding of planetary science. As we continue to explore and study this ice giant, who knows what other secrets we might uncover? Now, let us talk about the rotation period of Uranus. It completes one full rotation on its axis in approximately 17 hours and 14 minutes. This rapid rotation is quite fascinating, considering the planet's size. Uranus has a diameter of about 50,000 kilometers, making it the third largest planet in our solar system. Yet, it spins faster than Earth, which has a rotation period of 24 hours. One of the latest discoveries about Uranus, as of this year, is its complex magnetic field. Unlike Earth, where the magnetic field is relatively stable and aligned with the planet's rotation axis, Uranus has a highly tilted and offset magnetic field. This means that the magnetic poles are not aligned with the geographic poles, leading to a highly dynamic and complex magnetosphere. This discovery was made possible through data from the Voyager 2 spacecraft and recent observations from Earth-based telescopes. Another fascinating fact about Uranus is its ring system. While Saturn is famous for its rings, Uranus also has 13 known rings. These rings are much darker and narrower compared to Saturn's, making them difficult to observe. However, recent advancements in telescope technology have allowed astronomers to study these rings in greater detail. The rings are composed mainly of large particles, ranging from micrometers to meters in size, and are thought to be relatively young, perhaps only a few 100 million years old. Uranus also has 27 known moons, with the 5 largest being Miranda, Ariel, Umbriel, Titania, and Oberon. These moons are named after characters from the works of William Shakespeare and Alexander Pope. Recent observations have revealed that some of these moons may have subsurface oceans, similar to Jupiter's moon Europa. This has sparked interest in the potential for life in these distant worlds. In summary, Uranus is a planet full of surprises. From its rapid rotation and extreme axial tilt to its complex magnetic field and intriguing ring system, there is always something new to learn about this distant ice giant. As technology advances, we can expect even more exciting discoveries about Uranus and its moons in the coming years. Let's talk about the mass of Uranus. This ice giant has a mass of approximately 8.68 times that of Earth, which is about 8.68 x 10^25 kilograms. This makes Uranus the third largest planet in our solar system by mass, after Jupiter and Saturn. Despite its massive size, Uranus has a relatively low density of around 1.27 grams per cubic centimeter, which is less than half the density of Earth. This low density is due to its composition, which is primarily hydrogen and helium, along with water, ammonia, and methane ices. One of the most intriguing aspects of Uranus is its unique rotational tilt. Unlike any other planet in our solar system, Uranus is tipped over on its side with an axial tilt of about 98 degrees. This means that its poles are where most planets have their equators. This extreme tilt results in some of the most extreme seasons in the solar system, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. Recent discoveries have shed more light on Uranus's atmosphere. It is a dynamic and stormy place, with wind speeds reaching up to 900 kilometers per hour. These winds are driven by internal heat, as Uranus emits more heat than it receives from the sun. Interestingly, the atmosphere also contains a higher concentration of hydrogen sulfide, giving it a distinct smell reminiscent of rotten eggs. Another fascinating feature of Uranus is its ring system. While not as prominent as Saturn's rings, Uranus has a complex system of 13 known rings. These rings are dark and narrow, composed mainly of large particles, ranging from micrometers to a few meters in size. The rings are believed to be relatively young, possibly formed from the debris of shattered moons or comets. Uranus also boasts 27 known moons, each with its own unique characteristics. The 5 largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are particularly interesting. For instance, Miranda has some of the most varied and extreme terrain in the solar system, with giant canyons, ice cliffs, and surface features that suggest a history of intense geological activity. In recent years, there has been a growing interest in sending a dedicated mission to Uranus. Scientists believe that studying Uranus up close could provide crucial insights into the formation and evolution of ice giants, not only in our solar system, but also in exoplanetary systems. Such a mission could potentially reveal more about the planet's internal structure, magnetic field, and possibly even subsurface oceans. So, there you have it. Uranus may not be the most talked about planet, but it certainly is one of the most intriguing. From its massive size and unique tilt to its stormy atmosphere and mysterious rings, Uranus is a planet that deserves more attention. Uranus, the seventh planet from the Sun. While Earth has a diameter of about 12,742 kilometers, Uranus is significantly larger, boasting a diameter of approximately 50,724 kilometers. This means Uranus is nearly 4 times wider than Earth. But size is just the beginning. Uranus is unique in many ways. Unlike most planets that spin on an axis perpendicular to their orbit, Uranus rotates on its side. This peculiar tilt results in extreme seasonal variations. Each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. Imagine living through an entire lifetime of daylight or night. Recent data from the James Webb Space Telescope has revealed even more intriguing details about Uranus. For instance, the planet's atmosphere is made up of hydrogen, helium, and methane, giving it a cyan hue. The methane absorbs red light and reflects blue light, which is why Uranus appears blue-green to us. But the surprises do not end there. The telescope has also detected complex weather patterns, including massive storms and wind speeds reaching up to 900 kilometers per hour. These findings have provided invaluable insights into the atmospheric dynamics of Uranus. Uranus also has a ring system, though it is less prominent than Saturn's. First discovered in 1977, the rings of Uranus are composed of dark, rocky particles. Recent observations have detected 13 distinct rings, with the outermost rings being the brightest. These rings are constantly shifting and changing, adding another layer of complexity to this already fascinating planet. Another captivating aspect of Uranus is its moons. The planet has 27 known moons, each named after characters from the works of William Shakespeare and Alexander Pope. The largest of these moons, Titania and Oberon, are about half the size of Earth's moon. Recent missions have suggested that some of these moons might have subsurface oceans, making them intriguing candidates for future exploration. One of the most exciting developments in recent years is the proposed Uranus Orbiter and Probe mission by NASA. If approved, this mission aims to launch in the early 2030s and would provide unprecedented close-up views and data about Uranus and its moons. This could revolutionize our understanding of the ice giant and its place in our solar system. In summary, Uranus is a planet full of wonders and mysteries. From its colossal size and unique tilt to its dynamic atmosphere and intriguing moons, there is so much more to learn and discover. As our technology advances, who knows what other secrets Uranus might reveal? Uranus is a gas giant, similar to Jupiter and Saturn, but it is composed primarily of hydrogen and helium, with a substantial amount of water, ammonia, and methane ice. This composition gives Uranus its characteristic blue-green color. Unlike any other planet in our solar system, Uranus rotates on its side with an axial tilt of about 98 degrees. This unusual tilt results in extreme seasonal variations, with each pole experiencing 42 years of continuous sunlight, followed by 42 years of darkness. One of the most intriguing aspects of Uranus is its temperature. Despite being closer to the Sun than Neptune, Uranus is the coldest planet in our solar system. The planet's atmosphere reaches temperatures as low as -224 degrees Celsius, making it a frigid world. Recent studies suggest that Uranus may have a colder atmosphere due to its lack of an internal heat source. While Jupiter and Saturn emit more heat than they receive from the Sun, Uranus appears to radiate very little heat, leading to its extremely low temperatures. Another fascinating discovery is the presence of methane ice clouds in Uranus's atmosphere. These clouds form at high altitudes and contribute to the planet's overall chill. Scientists have also detected hydrogen sulfide in the upper atmosphere, a compound that gives the planet its characteristic smell, similar to rotten eggs. Uranus's magnetic field is another area of interest. Unlike Earth's magnetic field, which is aligned with its rotational axis, Uranus's magnetic field is tilted at 59 degrees relative to its axis of rotation. This misalignment results in a wildly varying magnetic environment, creating complex and dynamic auroras. The exploration of Uranus has been limited, with only one spacecraft, Voyager 2, having flown by the planet in 1986. However, there is growing interest in sending a dedicated mission to Uranus to further study its unique characteristics. In conclusion, Uranus is a planet of extremes, from its frigid temperatures to its bizarre axial tilt and complex magnetic field. The latest discoveries have only deepened our fascination with this icy giant, highlighting the need for further exploration. Did you know that Uranus has 13 known rings? That's right, 13. These rings were first discovered in 1977, and since then, astronomers have been diligently studying them to uncover their secrets. Unlike the bright and icy rings of Saturn, the rings of Uranus are dark and faint, composed primarily of large particles ranging from micrometers to meters in size. This makes them incredibly challenging to observe, even with powerful telescopes. One of the most interesting facts about Uranus's rings is their composition. They are primarily made up of water ice mixed with a dark material, possibly organic compounds. This gives them a unique appearance compared to the rings of other gas giants. The rings are also relatively young, estimated to be no more than 600 million years old. This is quite young in astronomical terms, suggesting that they may have formed from the remnants of a moon that was shattered by a collision. The rings of Uranus are divided into two groups: the inner 9 rings and the outer 4 rings. The inner rings are narrow and dark, while the outer rings are more widely spaced and brighter. The brightest and most prominent ring is the epsilon ring, which is about 100 kilometers wide. It is also the densest of the rings, containing the majority of the material. In addition to the rings, Uranus has 27 known moons, each with its own unique characteristics. The largest of these moons is Titania, which has a diameter of 1,578 kilometers. Titania is a fascinating world in its own right, with a surface covered in canyons, craters, and possibly even ice volcanoes. Another intriguing moon is Miranda, which has one of the most varied and bizarre landscapes in the solar system. Miranda's surface is a mix of deep canyons, ridges, and chaotic terrain, suggesting a history of intense geological activity. Scientists believe that Miranda may have been shattered and reassembled multiple times, giving it its unique appearance. The discovery of Uranus's rings and moons has provided valuable insights into the dynamics of the outer solar system. By studying these features, astronomers can learn more about the processes that shape planetary systems and the history of our own solar system. So, the next time you gaze up at the night sky, take a moment to think about Uranus and its incredible ring system. There is still so much to learn about this distant world, and who knows what other secrets it holds. Stay tuned for more exciting space discoveries, and do not forget to like, subscribe, and hit the bell icon to stay updated with our latest videos. Until next time, keep looking up. Uranus, the seventh planet from the Sun, often gets overshadowed by its more famous neighbors, like Jupiter and Saturn. However, this ice giant holds a treasure trove of fascinating secrets that make it a standout in our solar system. Discovered by William Herschel in 1781, Uranus is unique in many ways, starting with its peculiar tilt. Unlike any other planet, Uranus rotates on its side, with an axial tilt of about 98 degrees. This extreme tilt results in extreme seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. One of the most intriguing aspects of Uranus is its composition. Unlike Jupiter and Saturn, which are primarily composed of hydrogen and helium, Uranus has a higher concentration of ices such as water, ammonia, and methane. This gives the planet its characteristic blue-green color. The latest data from the James Webb Space Telescope has revealed that Uranus may have a complex, layered atmosphere with varying cloud structures. These findings suggest that the planet's weather systems are more dynamic than previously thought. Uranus also boasts a fascinating ring system, albeit less prominent than Saturn's. These rings are composed of dark, narrow, and widely spaced bands of rock and ice. Recent observations have shown that these rings are surprisingly young. Additionally, Uranus has 27 known moons, with Titania and Oberon being the largest. These moons are named after characters from the works of William Shakespeare and Alexander Pope, adding a touch of literary charm to the planet's scientific allure. Another captivating feature of Uranus is its magnetic field, which is tilted at 59 degrees relative to its rotational axis and offset from the planet's center. This creates a highly irregular magnetosphere, which scientists are still trying to fully understand. The planet's magnetic field is believed to be generated by a conductive fluid layer, possibly composed of water and ammonia, located beneath its icy mantle. In recent years, there has been a growing interest in sending a dedicated mission to Uranus. Such a mission could provide invaluable insights into the planet's atmosphere, magnetic field, rings, and moons. The European Space Agency and NASA have both expressed interest in exploring Uranus, with potential mission concepts including orbiters and atmospheric probes. These missions could help answer some of the most pressing questions about this enigmatic planet. Uranus's position in the solar system also plays a crucial role in its characteristics. Located at an average distance of about 2.9 billion kilometers from the Sun, it takes Uranus approximately 84 Earth years to complete one orbit. This distant location means that Uranus receives very little solar energy, contributing to its frigid temperatures. The planet's atmosphere is a chilly mix of hydrogen, helium, and methane, with temperatures dropping as low as -224 degrees Celsius. Despite its distance, Uranus has been a subject of fascination for astronomers and space enthusiasts alike. With new technologies and telescopes, we are continually uncovering more about this distant world. The mysteries of Uranus remind us that our solar system is full of wonders waiting to be explored. Unlike Earth, which has a magnetic field that is relatively aligned with its rotational axis, Uranus has a magnetic field that is wildly tilted. In fact, it is tilted at an angle of about 59 degrees relative to the planet's rotational axis. This means that Uranus's magnetic poles are not anywhere near its geographical poles. Imagine if Earth's North Pole was somewhere near Hawaii. That is how off-kilter Uranus's magnetic field is. But that is not all. Uranus's magnetic field is also offset from the planet's center by about 1/3 of its radius. This offset creates a magnetic field that is lopsided and highly irregular. The field strength varies greatly across the planet, creating regions of strong and weak magnetism. The reason behind this bizarre magnetic field lies in Uranus's internal structure. Scientists believe that the magnetic field is generated by a dynamo effect, similar to Earth. However, instead of a molten iron core, Uranus likely has a layer of ionic water, ammonia, and methane. These substances, under extreme pressure and temperature, become conductive and generate the magnetic field. The unusual tilt and offset are thought to be the result of the planet's unique rotation and internal dynamics. Recent data from the Hubble Space Telescope and the Voyager 2 spacecraft have provided more insights into Uranus's magnetic field. The Voyager 2 flyby in 1986 was the first to reveal the planet's magnetic oddities. Since then, advancements in technology have allowed scientists to study Uranus in greater detail. For instance, the Hubble Space Telescope has detected auroras on Uranus, which are caused by the interaction of the solar wind with the planet's magnetic field. These auroras are different from those on Earth and Jupiter due to the unique configuration of Uranus's magnetosphere. Another interesting fact is that Uranus's magnetic field is highly dynamic. It changes over time, influenced by the planet's rotation and interaction with the solar wind. This dynamic nature makes Uranus's magnetosphere a fascinating subject for study, as it can provide insights into magnetic fields of other planets and even exoplanets. Understanding Uranus's magnetic field also has implications for space exploration. The irregular magnetic field can affect spacecraft navigation and communication. Future missions to Uranus will need to take this into account to ensure successful operations. So, there you have it. Uranus's magnetic field is a complex and intriguing phenomenon that continues to puzzle and fascinate scientists. Uranus boasts a plethora of unique features that make it an intriguing subject for astronomers and space lovers alike. First, let us talk about its unusual tilt. Unlike any other planet, Uranus is tilted on its side, with an axial tilt of approximately 98 degrees. This means that it essentially rolls around the Sun like a barrel. Scientists believe this extreme tilt is the result of a colossal collision with an Earth-sized object billions of years ago. This unique orientation leads to extreme seasonal variations, with each pole getting around 42 Earth years of continuous sunlight, followed by 42 years of darkness. Next up is the planet's stunning blue-green color. This hue is due to the presence of methane in its atmosphere. Methane absorbs red light and reflects blue and green light, giving Uranus its distinctive color. However, recent observations have revealed that Uranus's atmosphere is more dynamic than previously thought. Storms and weather patterns are not as rare as once believed. In fact, the Hubble Space Telescope has captured images of massive storms, with winds reaching up to 900 kilometers per hour, rivaling the most powerful hurricanes on Earth. Now, let us explore the rings of Uranus. Although not as famous as Saturn's, Uranus has 13 known rings. These rings are dark and faint, composed mainly of large particles that range from micrometers to meters in size. The rings were first discovered in 1977, and ongoing observations have revealed that they are continually evolving, possibly due to collisions with small moons or other ring particles. Speaking of moons, Uranus has 27 known moons, each named after characters from the works of William Shakespeare and Alexander Pope. The largest of these moons, Titania and Oberon, are around 1,500 kilometers in diameter. Recent studies suggest that some of these moons may harbor subsurface oceans, making them intriguing targets for future exploration. Another fascinating aspect of Uranus is its magnetic field. Unlike Earth's magnetic field, which is aligned with its rotational axis, Uranus's magnetic field is tilted at a 47-degree angle and offset from the planet's center. This makes the magnetic environment around Uranus highly complex and dynamic, with intense radiation belts that could pose challenges for future missions. Lastly, let us not forget the recent discovery of hydrogen sulfide in Uranus's upper atmosphere. This compound, which gives rotten eggs their distinctive smell, suggests that the planet's atmosphere is rich in sulfur. The presence of hydrogen sulfide, along with methane and ammonia, provides crucial clues about the planet's formation and evolution. In conclusion, Uranus is a planet full of surprises, from its extreme tilt and dynamic atmosphere to its evolving rings and intriguing moons. As technology advances and new missions are planned, we can expect to uncover even more secrets about this enigmatic world. So, stay tuned and keep looking up. Voyager 2's journey to Uranus was a monumental feat. Launched in 1977, it took nearly 9 years for the spacecraft to reach the icy planet. As it approached, scientists and enthusiasts alike were on the edge of their seats, eager to see what secrets this enigmatic world held. The first glimpses of Uranus revealed a pale blue planet with a surprisingly uniform appearance, unlike the more turbulent atmospheres of Jupiter and Saturn. One of the most astonishing discoveries was the planet's extreme axial tilt. Uranus is tilted at an angle of 98 degrees, essentially rolling around the Sun on its side. This unique orientation results in extreme seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. Voyager 2's close encounter provided invaluable data, revealing that this tilt likely resulted from a colossal collision with an Earth-sized object billions of years ago. The spacecraft also unveiled a complex system of rings and moons orbiting Uranus. Unlike Saturn's bright and prominent rings, those around Uranus are dark and faint, composed primarily of ice and rock. Voyager 2 identified 11 new moons, bringing the total count to 27, each with its own unique characteristics. Among these, Miranda stood out with its bizarre, patchwork surface, featuring giant canyons, terraces, and regions that appear to have been pieced together haphazardly. Voyager 2's instruments detected a magnetic field around Uranus, but it was unlike any other in the solar system. The magnetic field is tilted at 59 degrees from the planet's rotational axis and is significantly offset from the center. This irregular magnetic field creates complex and dynamic auroras, which are still being studied today. Fast forward to recent years, and Uranus continues to intrigue scientists. Advances in telescope technology have allowed astronomers to observe the planet in greater detail from Earth. One of the latest discoveries is the detection of hydrogen sulfide in Uranus's atmosphere, the same compound that gives rotten eggs their distinctive smell. This finding provides clues about the planet's formation. Moreover, recent studies suggest that Uranus might have a subsurface ocean beneath its icy mantle. This ocean could potentially harbor life, making Uranus an even more compelling target for future missions. Plans for a dedicated Uranus orbiter are being discussed, aiming to launch in the 2030s. Voyager 2's visit to Uranus was a landmark event in space exploration. It not only expanded our understanding of the seventh planet from the Sun, but also highlighted the incredible diversity and complexity of our solar system. As we continue to explore and learn, Uranus remains a tantalizing mystery. Uranus, the seventh planet from the Sun, continues to captivate astronomers and space enthusiasts with its unique features and mysterious allure. Unlike any other planet in our solar system, Uranus boasts an extreme axial tilt of approximately 98 degrees. This means that the planet essentially rolls on its side as it orbits the Sun, leading to extreme seasonal variations that last for over 20 years each. One of the most striking features of Uranus is its mesmerizing blue-green color. This hue is a result of the methane present in its atmosphere, which absorbs red light and reflects blue and green light. The atmosphere itself is composed primarily of hydrogen and helium, with trace amounts of methane, giving it this distinctive appearance. Recent observations from the Hubble Space Telescope have revealed massive storms raging on Uranus, showcasing its dynamic and ever-changing weather patterns. These storms are thought to be driven by the planet's internal heat and the extreme tilt, which causes unusual atmospheric circulation. Uranus is also encircled by a system of rings, though they are much darker and more faint compared to the rings of Saturn. These rings are believed to be composed of ice and dark organic material, and recent studies suggest that they are evolving over time. The moons of Uranus are equally fascinating. Among them, Titania and Oberon stand out as the largest. These moons, named after characters from the works of William Shakespeare and Alexander Pope, are believed to harbor subsurface oceans beneath their icy crusts. The presence of these oceans raises intriguing possibilities about the potential for life in these distant worlds. Uranus also possesses a complex and unusual magnetic field, which is tilted at a significant angle from its rotational axis and offset from the planet's center. This magnetic field, combined with the presence of hydrogen sulfide in the atmosphere, creates a sulfur-rich environment that adds to the planet's unique characteristics. Understanding the formation and evolution of Uranus provides valuable insights into the broader processes of planet formation and the dynamics of our solar system. As space exploration technology advances, future missions to Uranus are being planned to uncover more about this enigmatic planet. These missions aim to delve deeper into the mysteries of Uranus, from its weather patterns and rings to its moons and magnetic field. In the ever-evolving field of space science and planetary science, Uranus remains a focal point of interest. Its extreme seasons, dynamic weather, and potential for subsurface oceans make it a prime candidate for future exploration. As we continue to push the boundaries of our knowledge, Uranus stands as a testament to the wonders and complexities of our solar system. Uranus, the seventh planet from the Sun, is often overlooked due to its distance and faint visibility from Earth. However, recent studies have unveiled fascinating details about this ice giant. Unlike most planets, Uranus rotates on its side with an axial tilt of approximately 98 degrees. This unusual orientation results in extreme seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. Scientists believe this tilt could be the result of a massive collision with an Earth-sized object long ago. The atmosphere of Uranus is composed primarily of hydrogen and helium, with a significant amount of methane, giving it a distinctive blue-green hue. The methane absorbs red light, reflecting blue and green light back into space. Recent observations from the Hubble Space Telescope have detected dynamic weather patterns on Uranus, including massive storms and cloud formations. These were previously thought to be rare due to the planet's cold temperatures, averaging -224 degrees Celsius. On the other hand, the Sun, our solar system's star, is a colossal ball of burning plasma, primarily composed of hydrogen and helium. It holds 99.86% of the solar system's total mass, exerting a gravitational pull that keeps all the planets in orbit. The Sun's core, where nuclear fusion occurs, reaches temperatures of around 15 million degrees Celsius. This fusion process converts hydrogen into helium, releasing an immense amount of energy that powers the Sun and provides light and warmth to our planet. One of the most recent discoveries about the Sun involves its magnetic field. The Parker Solar Probe, launched by NASA, has provided unprecedented data, revealing that the Sun's magnetic field is far more complex than previously understood. These findings have significant implications for understanding solar winds and space weather. This can impact satellite communications and power grids on Earth. Interestingly, while the Sun is a source of light and energy, Uranus is one of the coldest planets in our solar system, with an atmosphere that barely emits any heat. The contrast between the Sun's scorching temperatures and Uranus's frigid environment highlights the incredible diversity within our solar system. Moreover, Uranus has a faint ring system and 27 known moons, each with unique characteristics. The largest moons, such as Titania and Oberon, have surface features that suggest geologic activity, potentially driven by subsurface oceans. This has led scientists to speculate about the possibility of microbial life existing in these hidden waters. In conclusion, Uranus and the Sun represent two extremes in our solar system, one an icy giant with a mysterious past, the other a blazing star that sustains life on Earth. By studying these celestial bodies, we gain a deeper understanding of the forces that shape our cosmic environment and our place within it. Imagine a colossal planet with a serene blue hue, quietly spinning on its side, far away from the warmth of the Sun. Now, juxtapose that with an invisible, gravitational monster, a black hole that devours everything in its path, including light itself. Today, we explore the intriguing comparison between Uranus and black holes, two vastly different yet fascinating phenomena in our universe. Uranus, the seventh planet from the Sun, stands out with its unique axial tilt of 98 degrees. This tilt causes extreme seasonal variations, with each pole getting around 42 years of continuous sunlight, followed by 42 years of darkness. Uranus is composed mainly of hydrogen and helium, with traces of methane giving it a distinctive blue color. Recent observations using the James Webb Space Telescope have revealed more about its atmosphere, including the presence of complex hydrocarbons and a surprisingly dynamic weather system, with massive storms and winds reaching up to 900 kilometers per hour. On the other hand, black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are formed from the remnants of massive stars that have undergone gravitational collapse. The Event Horizon Telescope has recently provided us with a more detailed image of the supermassive black hole at the center of the Milky Way, known as Sagittarius A. This black hole has a mass of approximately 4 million times that of the Sun and an event horizon with a diameter of around 24 million kilometers. Despite their differences, Uranus and black holes share a common trait. They both challenge our understanding of physics. Uranus's peculiar tilt and its faint ring system continue to puzzle scientists. The planet's magnetic field is also unusual, being tilted at 59 degrees from its rotational axis and offset from the planet's center. This irregular magnetic field generates complex auroras, unlike anything seen on other planets in our solar system. Black holes, with their intense gravitational pull, warp spacetime and challenge the laws of physics as we know them. The study of black holes has led to groundbreaking theories in astrophysics, including the concept of Hawking radiation. Hawking radiation suggests that black holes can emit radiation due to quantum effects near the event horizon. This theory has profound implications for our understanding of the universe and the ultimate fate of black holes. One of the most exciting recent discoveries is the detection of gravitational waves, ripples in spacetime caused by violent cosmic events, such as the merging of black holes. These waves, first observed by the Laser Interferometer Gravitational Wave Observatory in 2015, have opened a new window into the universe. In summary, while Uranus and black holes are vastly different in nature, they both captivate our imagination and push the boundaries of our scientific knowledge. Uranus, with its unique characteristics and dynamic atmosphere, and black holes, with their mysterious and powerful presence, remind us of the complexity and wonder of the universe we inhabit. Uranus, the seventh planet from the Sun, has long fascinated astronomers and curious minds alike. But beyond its scientific allure, Uranus holds a unique place in various religious and mythological traditions. In ancient Greek mythology, Uranus was the personification of the sky and the husband of Gaia, the earth. He was considered one of the primordial deities, emerging at the dawn of creation. The union of Uranus and Gaia produced the Titans, the Cyclopes, and the Hecaton-Kyries, among others. However, Uranus's relationship with his offspring was far from harmonious. Fearing their power, he imprisoned them within Gaia, causing her great pain. This led to a dramatic confrontation where Cronus, one of the Titans, overthrew Uranus, symbolizing a shift in cosmic order. Fast forward to modern times, and Uranus continues to inspire spiritual and astrological interpretations. In astrology, Uranus is often associated with sudden change, innovation, and rebellion. Its influence is believed to bring about unexpected events and breakthroughs, challenging the status quo. This association with change and revolution is fitting, given Uranus's unique rotational axis. Unlike any other planet in our solar system, Uranus rotates on its side, creating extreme seasonal variations and a sense of unpredictability. Interestingly, recent observations have provided new insights into Uranus's atmospheric composition. The planet's blue-green hue is attributed to the presence of methane in its atmosphere, which absorbs red light and reflects blue. However, recent studies using the James Webb Space Telescope have revealed traces of hydrogen sulfide, a compound that gives rotten eggs their distinctive smell. This discovery adds another layer of intrigue to the planet's already mysterious nature. In the context of Hinduism, Uranus does not hold a significant place in traditional scriptures. However, the planet's association with sudden change and innovation can be linked to the concept of pralaya, or cosmic dissolution. This cyclical process of destruction and creation resonates with Uranus's astrological symbolism. In more contemporary spiritual practices, Uranus is often invoked in rituals aimed at fostering personal growth and transformation. Its energy is considered potent for breaking free from old patterns and embracing new possibilities. This makes Uranus a powerful symbol for those seeking to reinvent themselves or their circumstances. The astronomical community continues to be captivated by Uranus's enigmatic characteristics. One of the most recent discoveries is the presence of 27 moons orbiting the planet, each named after characters from the works of William Shakespeare and Alexander Pope. Among these moons, Miranda stands out due to its bizarre surface features, which include giant canyons, terraces, and a patchwork of different terrains. These features suggest a history of intense geological activity, adding to the planet's mystique. As we look to the future, missions to Uranus are being planned to uncover more of its secrets. The proposed Uranus Orbiter and Probe mission aims to study the planet's atmosphere, magnetic field, and interior structure in unprecedented detail. Such missions promise to deepen our understanding of this distant world and its place in the broader context of our solar system. In conclusion, Uranus is not just a distant ice giant. It is a symbol of change, innovation, and cosmic mystery.